Welcome to Ask and Learn.
For problem 15.188, we know that the rotor of the motor rotates about the z-axis with a constant rate of 1,800 revolutions per minute, and that the motor itself is rotated about the y-axis with again a constant rate of 6 revolutions per minute. And we've been asked to calculate the value of the angular acceleration of the rotor specifically. Before we begin, let's convert revolutions per minute to radians per second. This is easy to do. We just have to multiply by 2 pi because one revolution corresponds to an angle of 2 pi, and then divide by 60 seconds, giving us about 188.496 radians per second. And again, 6 times 2 pi divided by 60, giving us approximately 0.628 radians per second. Next, we have to choose a rotating frame in order to make use of the very useful formula that the angular velocity, the angular acceleration, as seen from a fixed frame, can be expressed in terms of quantities of a rotating frame. And this is, let's denote the rotating frame by prime indices. So this is the formula. This is the rate of change of the angular velocity as seen from an observer on the rotating frame. This omega capital is the angular velocity of the rotating frame, and this omega small is the angular velocity, specifically now for the rotor as seen from an observer on the rotating frame. Let's pick firstly a rotating frame for convenience. I hope it is obvious that we better choose a rotating frame that rotates with the model itself. So this is a rotating frame which rotates about the y-axis with an angular velocity exactly the same as the one for the motor. An observer on this rotating frame won't see any change, any rate of change for the angular velocity of the rotor. So this goes to 0, and the only angular velocity that a rotating observer will see is just the one for the rotor. So combining this, the angular acceleration is just the cross product of omega 2 times omega 1. And let's put the values now. So the acceleration, the angular acceleration is 0.628 j hat, because direction of omega 2 is along the y-axis, counterclockwise, as someone can see from the drawing, times 188,496 k hat, because vector omega 1 has direction towards the positive z-axis, because the rotation is again counterclockwise as seen from the positive z-axis. And finally, this gives us radians per second per second. This is it.